Welcome everyone to Chaining Compose Modifiers Beyond Intuition. I'm Meike Felicia, I'm the Android lead of Adesso Mobile Solutions, which is part of the Adesso group. And yeah, we are specialized on mobile enterprise solutions, so different industry flavors and a lot of fun. So let's see what we can do with modifier chaining. And first of all, put us all on the same page and define what a modifier is and what it does. And actually, it's there to decorate and augment composables, going to mold them the way you want and need them. Exactly speaking, it means you can change the size of a composable, the layout, its behavior, and also the appearance of our composable, and add additional information like accessibility labels, process some user input normally, make it, of course, mostly clickable, then scrollable, draggable, or also zoomable if you need it. So actually, that's a large set of options you've got, and huge combinations can happen. So what's the problem with that? Can we chain like everything, everywhere, all at once, or does the order probably matter at some point? You see the picture with the pancakes, and I hope you are as much as a pancake fan as I am. And if I would have to imagine someone doesn't stick to the recipe, like putting the syrup inside the pan and then whatever milk afterwards over it, would probably taste very awful. So order can matter in some cases, definitely. But when it comes to unstructured eating order of pancakes, I totally don't mind, would just eat them all. Let's jump right into some intuition regarding modifiers. Here's the first example, and you see actually two boxes as composables, and they have the same set of modifiers applied to it. So each is having two borders surrounding, inside, a padding modifier, and also a size modifier. All padding modifier and size modifiers using the same DP values. So actually, just by swapping the position, it changes to the different result. So how does that happen? Because we are using same sizes, and anyways, looks very different. For reference, I did add another rectangle thing at the lower bottom, which actually, for reference, just shows your exact size. In that case, we have a rectangle of 200 dp, and if you try to combine it with the upper rectangles somehow, it seems like the one in the middle matches with the magenta color version in 200 dp size, and then the upper one, only the blue rectangles seem to match our reference rectangle. Why is that? Let's check out the source code for our first box. So the border modifier comes in, says like, I want to have a blue border, don't know where to place it yet, but give me some size. So size modifier comes in, says 200 dp, and actually it gets placed at 200 dp. Afterwards, the following modifier says like, make an inset padding, so inside intrinsic of 16 dps, and that's where the magenta version actually is going to be placed. On the other hand, like the larger one, our next box is just really swapping the position of padding and size, and that leads to the result that the blue border coming in again, and then our padding appears and say, okay, I could, whatever size I should finally have, I will add another 16 dp to that. And then you see our size modifier coming in, which actually sets the size for all following modifiers. And that's why the magenta version in the second case matches our 200 dp size. So can be quite counterintuitive. Another sample for beyond intuition stuff regarding modifiers could be that you, for some reason, add multiple size modifiers. Maybe you just have a very long set of modifiers, or you are passing modifiers through composables to the next one, and actually lost track which modifiers are all there and which are given. So first example, the upper one is like you try to apply a size modifier of 5 dp. What happens then actually? Do we still fill our max size space, or is it now 5 dp because that was the last modifier? Very unsure. Does it have any impact? So not very intuitive what happens then. Same thing for the second example. We have a fill max size again, and then a wrap content size modifier. Just we want to have everything wrapped as it should be. Unsure what could happen in that case. If you see the results, the upper one is just due to aspect ratio. You see the gray area, but it's still filling max size. It's definitely not a very tiny 5 dp thing. So seems like our second size modifier has been ignored totally. When it comes to the second example, there's something happened, but actually not really just our wrap content size thing, because it would reside on the left upper corner in that case. So seems like something different happened. It's centered suddenly. The cause of that is that it's still filling the max size, so our layout node of that image still fills up the entire space. Just additionally, the wrap content size is applied to a centered version of our image. So this. And then another possibility could be, it's like, man, it's not working. We force the size. We really want to have 50 dp, so we apply our required size modifier. And if we are when we are forcing things, it actually should have an impact and be that size. But yeah, as you can see, the layout node would actually still fill max size. Also, like in the wrap content sample, it's just centering our sized planet's image to 50 dp. So it's actually still, not only the size modifier. How to tackle issues like that, that we can foresee what's the effect of several size modifiers and what would happen when we change several modifiers like that. Actually, it's a good starting point to learn about constraints and the layout phase. So let's have a look. Since the layout phase resides in our compose phases, a short recap on that. So the composition phase says like what we want to show. We define our UI tree probably, and then the layout phase says where we want to place it, and in the drawing phase we finally decide how to render it. And when you see the image like coming from data to UI, I also added in the layout phase and in the drawing phase some modifiers, and probably notice that the most size modifiers are residing in our layout phase, because that's the thing where we place stuff and measure things. And things like clip, rotate, scale, draw behind, all these graphics modifier are residing in the drawing phase. Why is that important to know about phases, and especially the layout phase? There's an algorithm which is going there with 3 steps, which are important to remember, because like each layout node will first start measuring its own children, then deciding the own size, and finally placing their children. So process for each node. And that's where constraints come into the game, because they help finding the right size for the first 2 steps in that algorithm. Short definition on constraints, so it's just the min and max bounds for layout node on each axis. So we have a width min max value, and we have a height min max value. And of course, there are several types of constraints, so we just go over a short theory part here. But there are bounded constraints, like I said, with a min-max value. So in that case, our layout node could have a width between 100 and 400, and also a height between 100 and 400. We have also unbounded constraints, where we can just go from 0 to infinity, in that case in all directions, height and width. And additionally, there is of course also the exact size of a constraint, where just the min and max value for each bound of the axis are set to the same size. So we can say like min is 300 and max value of width is also 300. And in case of height, we also have only the option to go from 200 to 200. And additionally, you of course have to imagine you can combine all these types of constraints. So the sample for bounding width, but having an unbounded maximum height, like our height can go from 100 to infinity, and the width can go from 100 to 400. Or we could have an exact width and providing a bounded height, the exact width of 600 and a bounded height of 0 to 400. So now you know the different types of constraints, but probably still wondering how they are coming to action, what is their life cycle. And actually, they are always passed down from parent to child inside the UI tree during our layout phase. And still, each parent measures its child, and then when it knows its own size, it communicates the size back up to the UI tree. Could look like this. So we have an UI tree. Root node is a row, and first leaf child a padding. So actually, the row passes our constraints to the padding, and then finally, for each leaf, the size will bubble up our tree. For some animation fun, we're going to traverse that now on a sample. So we have a free space of 600 and 300, probably also coming in from our parent node. So these are the incoming constraints we've got. Afterwards, the row says like, yeah, cool, fine. I could take 600 by 300, but still don't know yet what I want to show. So probably just pass our constraints to our first child. And that is a padding modifier wrapping a column inside. So actually, it has a start of padding of 16 and will reduce the available space for its following children. Then the column comes in and actually gets its constraints, which are reduced in the width and only now 584. Okay, but the column again doesn't know what size it is because it can show several items inside. So we'll just again pass the constraints to its child. We have again a padding modifier wrapping a button, which is actually showing some text. Imagine just the text length leads to a size of 140 by 82. And of course, the padding modifier again, we're reducing the size first on the top, and then the available space for our button appears. And actually calculating all the stuff, we realize the size of our button would be, the size with the button and the padding would be 140 and 98. That's why like 82 plus 16 will get our height. And then since we know our size, we can report that back, place the button, and go to our next leaf. We have now left some width of a range from our constraint between 0 and 584, and also a height of 0 to 202, just leading because of our first child inside the column took already some space, and also the padding modifier with a start of 16 dp. So again, we have another button which seems to have less text because the width is only 119, and of course, but having the same height. So easy on that, it's just reporting I'm having that width. So coming back, placing the button, and then coming back to our column, it can now combine min-max values and say, okay, we are now 140 width and 180 height. let's go to the, actually that's still missing the padding modifier size, so we have to add that up and get our final result for that, so we can go to our next child of our row. And there, actually, we still have all the amount of our height, because that, in case of a row, doesn't play a role at that point. But the width is already reduced by that starting padding. So here we have a rotating modifier. I animated it now a little bit too early, but doesn't care. In that case, that rotation doesn't change anything in our size, so just fine with that. We just have a size of 100 from image, which is inside, and it can paint itself at the size of 100 and 100. So easy size calculation on that. Can just report back, and then finally our root node can get its size by checking out which is the max value on the height side, and then summing up our width values, which leads to a result of 256 and 180 height. And actually that's how constraints traversing through the UI tree, going down and bubbling the size back up. Back to some examples after all the theory. What happens if you define a size which is actually out of range of the incoming constraints? Imagine you have a width of 100 to 200 and a height of 100 and 500, but want to draw something like an image with the size of 600. What would happen then? Actually, with still respecting the incoming constraints and adapting as closely as it can, it would then have the incoming constraints of 200 by 200, so min-max, same value, and 500 by 500, because that's the maximum we can get. We cannot get any more here, nothing to do. Also, in case of being too small, we are forced to respect the incoming bounds again, and actually our image will show up at 100 and 100 instead of having a size of 80 like we wanted to. At some point then it happened to me that I was wondering, what's the relation of a constraint to a modifier? Do they have a relation? Do they, is there something they have in common or something? And actually you can see it that way, that constraints are affecting the size of the composable, and modifiers then affect the constraints in the first place. So it's, like a little game in between of them. So let's jump into another more, I would call it an intuitive example, but let's see. If you imagine you have a padding modifier, a background, and a border modifier applied to a text composable, you can actually achieve all these results just by swapping their position. Which one is which? We'll see that. Actually, just one sample, now you're seeing the order inside the text. And if you notice, the padding modifier is the one that goes from first position to center position, and then at the final position. And of course, the last one is looking the best, so probably that's the one we wanted to achieve. Why is actually the order in that case like that? Anyway, if it's intuitive, I anyway explain it now. So we have the padding, which is going to be in our first version where the padding modifier is applied first. It's going to do that outside padding again, and then just applies the background, and the border is like really tightly up to it. If we, in the second case, want to have our background first, gets a nice size, but then padding pads like an intrinsic thing for a border modifier. So probably we just want to pad our text and not the border, which would happen if you place the padding modifier at last here. So that's the result we want to have. Yeah, another surprising example for me was the combination of scaling and offset. these are just 2 box composables, and I swapped. Actually, I think they also have a same size modifier, but just by swapping the position of scale and offset, we can have very different results. Like one seems, the blue one is much further right, and the magenta one seems like scaled not that much. So the blue one was scaled and then moved to the right, and the magenta version was moved first with an offset. I mean, before it was, yeah, it was scaled first. Let's just check the source code in that case. So we see now the source code for the blue modifier, and actually scaling comes in first. So it's also applied to the offset, obviously, because yeah, it goes further to the right. In case of our magenta version, we apply the offset first, and then the scale coming in, which seems like the scale does not get applied to our offset at all. Some programming languages like scale from the originated center thing, but in that case doesn't happen like that, so you have to watch out what you want to scale and if that offset should be a part of it or not. Another example for that, actually, I wrote a little gradient modifier, even not really necessary to do that, but yeah, just imagine you have a gradient modifier or some other cool thing you customly wrote. That thing resides also in the drawing phase because it's a graphics modifier, and yeah, just take some color for start to end, and yeah, we'll draw from start from top to bottom actually because it's a vertical modifier. And here again, we want to add some more stuff to it, another drawing phase graphics modifier called clip, which gives us that nice round thing. And actually what we want to accomplish is that round shape. But just by swapping their position again, you can see either the left-hand result or the right-hand result. And let's see how that happened. So in the first version, the unwanted result actually is applying the gradient overlay first, our custom modifier, and then clipping it. And seems like clip doesn't have any impact on that, and nothing is falling afterwards, so we do not see anything about whatever should have been clipped, but there's nothing clipped. In the second example, you can see we clip first, so it applies that to all following children, and in that case, our gradient overlay is coming in, and that's finally how it gets clipped, and we have the result we wanted. So actually, seems like, order matters. It's influencing the size and the shape and also the behavior of our composables, because if you think about touch areas, that was hard to show in in a presentation, but even like touch areas affected by that very much. So watch out if you scale too much and make size offset things. Probably the touch area is at some other place you would have expected it. But in general, it's a good strategy to read modifiers from top to bottom. Just watch out that they are counterintuitive in some cases, like with the offset and scale modifiers. And then also, you have to notice that some modifiers can apply it multiple times, like our border modifier, and some are just ineffective, like applying several size modifiers in a following structure. Yes, so that's just the main info I want to hand over to you when it comes to ordering modifiers, and that's actually already it from me. Thank you very much. We're hiring, and reach out.